Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we will go over checkpoint 6.18. This is coming from section 6.4. It says to find the binomial series for this function f of x is equal to 1 divided by 1 plus x quantity to the 3/2 power. So here we have the binomial series theorem that says 1 plus x raised to the r power is going to be equal to the sum as n goes from 0 to infinity of this is r choose n. It's a special formula that takes an r and an n as an input and then times x to the n. Now r choose n is going to be some sort of number value that takes the power and then uses the n for whichever n you're dealing with, and then it has this particular formula. Alright, so let's see if we can work this out and try to find the general series for this particular problem. We have, well, if we write this as 1 plus x to the negative 3/2 power, then we can identify that r in this case is equal to negative 3 over 2. And once we know that, then we can set up our series. So our series then will look like 1 plus x to the negative 3/2 will equal to, okay, we'll start off with 1. And then we have r, that's negative 3 over 2 times x. So that's r. And then we have, this is going to be r choose 2 for the second term. So our r is negative 3 over 2. So according to this is going to be negative 3 over 2. And then we have negative 3 over 2 minus 1. So that's negative 5 over 2. And then divide the whole thing by 2 factorial. And then we have x squared. So in our third term, for the third degree term of our polynomial, we're going to have negative 3 over 2, we'll subtract 1, negative 5 over 2, and then we'll subtract 1 more, negative 7 over 2, and then all divided by 3 factorial this time. And then multiply that by x cubed. And then so let's do one more, just so we can get a feel for the pattern. It's negative 3 over 2, negative 5 over 2, negative 7 over 2, and then subtract one more, negative 9 over 2. So we can see that the numerators of the numerator will be all odd numbers from 3 to whatever you stop at. And the denominator will be 4 factorial, since we are looking at the fourth term here, or the fourth degree term, and so on. All right, so now in terms of trying to simplify things and trying to find a pattern, it looks like we have a positive 1, and then now we have a negative 3 over 2. So I think there's going to be an alternating part to this series. We have negative times a negative is a positive, and then that 5 times 3, we'll say 3 times 5 in the numerator. And then we have 2 times 2, and then a 2 factorial. Now we can multiply all that stuff out, but I think it might be better if we leave it as 2 squared times 2 factorial for now, and then just for the sake of finding a pattern. And then we have the x squared. So now the next term will have 3 negative signs. That'll eventually be a negative. In the numerator, we'll have 3 times 5 times 7. And then we'll divide by 2 times 2 times 2, so that's 2 to the third power times 3 factorial, and then x to the third. So we're kind of getting a feel for the denominator here in the numerator. Looks like it's going to be a product of a bunch of odd numbers. The next one has 4 negative signs. That will amount to be a positive number. 3 times 5 times 7 times 9, divided by, now there's 4 2's, that's 2 to the 4th power, that's coming from the denominator and the numerator, and then we have 4 factorial, and then x to the 4th. Okay, so I think we got a good feel for this. Let's see, to get our general term, it's an alternating series, so it's -1 to the nth power. Let's try the nth power, and let's get this guy, or get the series to start from 0 to infinity. So it's going to be to the nth power, and then in the numerator there's a kind of an understood 1 here that we're multiplying everything by. So this is 1 times 3 for the first one, and the first one is just be 1. So it's going to be 1 times 3 times ... and then I'll say 2n minus 1. For n is equal to 0, this will be -1. Actually, that won't work. So when n is equal to 1, this would be 2 minus 1. So I think this is a plus. And then, so that takes care of the product of the odd integers up in the numerator. And then in the denominator, we'll get 2 to the nth power. So it looks like for the third term, we have 2 to the third, etc. And there's going to be n factorial that we're multiplying, and then x to the nth power. All right, so we can verify that by putting 0 in. And then we're just going to have 1 in the numerator, and then 0 factorial is 1, and then x to the 0 is going to be 1. So the whole thing is going to be 1, so that checks out. When we put n is equal to 1 in here, this will be negative, because -1 to the first power is -1. And then -1, the last term in the numerator would be 2 times 1 is 2, plus 1 is 3, so it's going to be 1 times 3. And then we have to the first power, 2 to the first power is 2, and then 1 factorial is 1, and then this would be x to the first power, so that's 1 times 3 divided by 2 times x. And then one more, when we put n is equal to 2, this would be positive, and this would be 2 times 2 is 4, plus 1 is 5, so it's going to be 1 times 3 times 5 in the numerator, 2 to the third, or 2 to the second, 2 factorial, and x squared. All right, so I think that's it, and this is our final answer, and I hope that helps. Good luck.